Okay, we're back. This is Techmath1. We're looking at chapter 8, specifically 8:11, which is on 355 in the blue book. So they want to know on 114 which one of these we could split up as like the sum or difference of two fractions. And so A, we could do that because look, we could write this as m over m plus 5 over m. We could actually reduce it then and write it as 1 plus 5 over m. This one, we couldn't do that. We can't split that up because you can't. It's the denominator. The numerator has to be the two-term, the binomial, and the denominator has to always be, if you're going to split it up, the denominator has to be a monomial, a single term. So that one's out, that one's out. This one we could split up. Write it a over ab minus b over ab. That one we could actually reduce both of them. So that would be 1 over b minus 1 over a. All right. 8:12, we're actually factoring out the greatest common factor. And so the largest thing that'll come out of both of those numbers, and it's going to be like the opposite of the distributive property. Like when I have this, 9 times p minus q, we do the distributive property where we multiply that by p and we multiply that by q. And we have 9p minus 9q. To do factoring, factor out the greatest common factor, you're doing the opposite of that. So instead of multiplying, you end up dividing. And instead of distributing, you kind of pull something out. And so the greatest common factor is the largest number that goes into 9 that also goes into 9. Well, that is 9, of course. So what you do is you write the GCF out front. You do an empty set of parentheses. Then to figure out what goes inside of those parentheses, you divide by whatever you wrote out front here. So 9p over 9, that's just p, minus 9q over 9, that's just q. And you're done. Let's look at this. What is the largest thing that'll come out of 8 that'll also come out of 4? The answer is 4. If you said 8, if you just said 8, you're thinking of the lowest common denominator, the lowest number they both go into. We want the largest number that goes into them. So there's a default GCF. The default GCF is 1. You can always pull 1 on everything. So if they don't have anything in common, 1 will come out. All right, but these do have something in common, 4. So 4 comes out, you write it out front, in front of the parentheses, you divide that by 4, you divide that by 4, and then that is 2x plus 1. So whenever you factor out, you write it out in front, and then do an empty set of parentheses, and then write it underneath each term, and then reduce it term by term. That's how I got the 2x plus 1. Let's do this one. What is the largest number that comes out of 4 that also comes out of 20? Greatest common factor there would be 4. And so you could divide by 4, and then, so you write the 4 down in front, an empty set of parentheses, then you go back, divide it by 4, each term, and so that is 1d, and that is 5. Okay. And then let's say that you didn't know 4 on either one of those. You could do it like this also. There is an algorithm where you break it down, or d, 2 times 2 times d, and 20 is 2 times 2 times 5. And like how we found the lowest common denominator, the greatest common factor, though, you only take what they have in common and nothing else. You leave the other ones behind. So that's 4. And so that's a way to get that. Now, you don't always have to do that. Most people can just kind of look at it and go, oh, the largest thing that goes into both numbers. And you can avoid all that work. All right. The GCF would be 2. And then whatever I wrote out front, I put it underneath each term, and then I reduce it term by term. So that's h plus 4t. All right. So So that's factoring. Again, you should have seen factoring before. Right now, I hope this is just review. All right. So let's take a look at 8.13. Reducing patterns to lowest terms. So 128. I'm going to take a look at 128. 8.13. Okay, so identify. So let's see, we got 2p over 2q minus 2t. All right, lovely. Identify the common factor in each term of the numerator and denominator of these. Okay, so here, we're going to do more than that, though. We're going to also reduce it. It's silly for us to factor and then not reduce. So 3y plus 6 over 3x minus 9. Okay, so what they want us to do is where there's binomials, they want us to factor. So just what we just did before. So on the bottom, I could factor out a 2. So on the top, it's 2p. On the bottom, I factor out a 2. I do an empty set of parentheses. And whatever I wrote out front, I put it underneath each one. And then I reduce it term by term. So q minus t. All right? So we could reduce this fraction by a factor of 2. Because look, the 2's cancel, and then I have p over q minus t. If you want to keep the parentheses on the q minus t, you can. But you don't have to, because if you have the big long line, the parentheses are implied. All right? What can we factor out of the top there? We could factor out a 5. Divide that by 5, divide that by 5. So we have r minus 2. Then on the bottom, 15q. So that we could reduce by a factor of 5. Because the 5 would cancel into that 3 times. And then we just have r minus 2 over 3q. Let's do this one. We could factor, top and bottom, numerator and denominator there. 3 comes out on the top. We get y plus 2. And 3 comes out on the bottom. And we get x minus 3. And then what we can do is reduce that by a factor of 3. Which means those 3's cancel. So y plus 2 over x minus 3. You can only cancel things that are being multiplied. Notice, this was 5 times that quantity. This is 5 times 3 times q. So it's being multiplied, so you can take them out. You can't take out little pieces of things that are being added or subtracted. For example, if this was an x plus 2, we could not cancel those x's. The only way you can get rid of a binomial that's being added like that is with the exact same binomial. You can't do little pieces of it. All right? So only cancel things that are being multiplied. And then let's take a look at 8.14. So we got 146, and that's 3 plus 3x over 3, and they want me to reduce that, and that's pq minus p over p. They want me to reduce that, so let's have at it. We can factor out a 3 on the top, and I divide by 3, whatever I write out front, I put it underneath and then reduce it term by term. So 3 divided by 3 is 1. 3x divided by 3 is x. The plus still stays there. And then the 3's cancel. And I just have 1 plus x. This one, I can factor out a p on the top. And so I divide by p, I divide by p. P's cancel, I get q. P's cancel, I get 1, and then minus. Be careful with that. Really, really, really common error are students put 0 when they're thinking minus. And I know why. You see a big minus sign in front of there, but you're actually dividing here. P divided by P is 1. And then that's over P, and so those P's cancel, and you end up with just Q minus 1. All right. Lovely doubly. Then 815, I gotta tell you, I don't really care for how they call these. They're calling them complex fractions. They're actually compound fractions. Complex is a mathematics term that means you're working with imaginary numbers. And we actually do that. We're gonna look at imaginary numbers in Techmath. I'm not sure if it's Techmath1 or 2, but we are gonna look at those. Engineers use those all the time. In electrical engineering, when there's like a charge being held, they'll use complex numbers or imaginary numbers. And in aerodynamics, to design aerodynamics, they use complex numbers, algebraic numbers. And so they really, really, really shouldn't call on 815 these complex fractions. They're not really complex. They're compound, meaning that they have a fraction and then another fraction, a fraction in the numerator or denominator, or both. So like a fraction over a fraction. That's a compound fraction, not really complex, but oh well. T plus 1 over t. Okay, so again, these look really difficult, but they're not that bad. So let me show you how to do those. You write this like over 1, and then you look at 1, 1, and q, and you find the LCD. So the LCD between all 3 of those is q. And then whatever you find the LCD to be, you multiply each term by that. So you multiply that by q, you multiply that by q, you multiply that by q. So each term gets a cube attached to it. Basically what I'm doing is I'm multiplying numerator and denominator by the same thing, q on top, q on bottom, and just distributing the q over this binomial. So it's easier just to think, just tack it onto every term, all right? Then look at what happens. These q's cancel. So on the top, I have PQ. On the bottom, I have QP or PQ again. And then I have minus P. And so I can reduce this. Ooh, it's getting a little tricky here. So I can reduce this now because I can factor a P out of the bottom. So I have PQ on the top. I can factor the P out of the bottom and get Q minus 1, but now look at what I can do. I can wipe out those P's. Q over Q minus 1. And that's where the show stops. Do not do anything silly like canceling Q's. That's being added or subtracted. You can only cancel things that are being multiplied. So this is being multiplied by the binomial. We can get rid of those P's. Q on top, Q minus 1 on bottom. This is its own thing. That is a binomial. The only way you can get rid of that is if there was exactly the same binomial on the top, like a Q minus 1, and there isn't. It's just a Q. So careful. That's a really, really common error. So this one, what's going to happen here is between t and 1 and t, the LCD is t. And so you find the LCD, but then you just multiply every term by that LCD. And now look at what happens. These cancel away. That's t squared minus 1 over t squared plus 1. And we can't do a thing with it. That's all. That's it. I mean, if you know you're factoring, you know you could factor that into t plus 1, t minus 1, but it still won't cancel with that because it's t squared plus 1. So you cannot do a thing because that's an addition sign and that's a subtraction sign. If those were gone, we could totally reduce the t squareds, but they're not. So notice. So that was it for chapter 8.